Hey everybody, it's Mr. Mott. What we're going to do is talk about how to do these multi-step stoichiometry problems. And the guy on our screen there is sort of responsible for it all, so you can blame him. It's Amadeo Avogadro. He came up with some of the ideas that we use today. And so let's get started. So some background information that we first talked about was that 1 mole is going to be equal to 6.02 times 10 to the 23rd, either atoms or molecules. Sometimes we generically call those particles. That's the conversion factor that we're going to use anytime we're dealing with atoms and molecules. Now in the factor label method, sometimes we're going to write our conversion factor almost like a fraction with moles on top and atoms or molecules on the bottom. Depending on the problem, we might need to flip that over. We then learn that those number of particles, 6.02 times 10 to the 23rd particles, on a big scale is going to be equal to the grams on the periodic table. In other words, the molar mass is equal to the atomic mass on the periodic table. And again, what we do is we can write that conversion with 1 mole over a certain number of grams. It's going to be different for every element, or we might need to flip that over. The last thing that we learned was that the units in the equation are actually moles. So the equation allows us to compare moles of one chemical to moles of another. And so generically we say moles of A to moles of B. And if we're turning that conversion factor into a fraction form, we could have moles of A on top and moles of B on the bottom, or we could flip it over. So let's take a look at how this works in a series of problems, and using the factor label method, how do we know where to get the numbers from, and how do we set everything up? So if we have a balanced equation where it says 4 Fe plus 3O2 produces 2 Fe2O3, we want to remember that those units are moles. So really, a chemist would read it 4 moles of Fe plus 3 moles of O2 will produce 2 moles of Fe2O3. So if we then pose the problem, so this is our balanced equation, well, just like a recipe, we don't always use the recipe exactly as it's written. Sometimes you need to double the recipe, triple it, depending on our ingredients. So if we say how many moles of oxygen are needed to react completely with 15 moles of iron, Fe, so we're going to set up our problem with our given information and our wants. So we have 15 moles of Fe as our given, and what we want to find out are moles of O2. So in the factor label method, we put moles of Fe on the bottom, and since we want to find out moles of O2, and we do know that relationship, that's an important idea, we can compare moles of Fe to moles of O2 using our equation, so then I can put moles of O2 on top. Once we have the unit in place, we look to our balanced equation, which compares moles of one chemical to moles of another, and we grab the numbers. So in front of oxygen there's a 3, in front of iron there's a 4. We can see that our units cancel out, and we're left with the units of moles of O2. Now it's a matter of doing the math. 15 times 3 divided by 4 will give us about 11.25 moles of oxygen. If we were to expand this and think about grams, and that's what a chemist is really focused on, is grams, because that's what we weigh out in lab. So if we ask you the question, how many grams of oxygen are needed to react completely with 15 moles of Fe, our given information is the same. Now what we want to find out are our grams of O2. So since we don't want moles of Fe, we cancel them out by putting those units on the bottom. Now we don't have a relationship between moles of iron and grams of oxygen, but we do know a relationship between moles of iron and moles of oxygen. So very similar to the last problem, the first step is the same. We grab the numbers from the equation, and we can see that our units of moles of Fe do cancel. Okay? The units we have left are moles of O2, which is not what we want. We want to find grams of O2. So we put the units in the next conversion factor of moles of O2 on the bottom. Now we do have a relationship between grams of O2 and moles of O2, so I can put grams of O2 on top. Now as far as the numbers go, when you see the units of grams over moles for the same chemical, real important, the same chemical, that's molar mass. Molar mass is if I have 1 mole of this substance, I can find out the molar mass from the periodic table. So oxygen's molar mass is 16, but since it's O2, 16 times 2 is 32. We can see that our units of moles of O2 cancel. We're left with grams of O2 as our units. So now we're going to do the math. 15 times 3 times 32 divided by 4 should give us about 360. So we can expand this a little bit and say, what if we wanted to find out how many grams of oxygen are needed to react completely with 30 grams of iron? So now we're starting with grams of iron instead of moles of iron. So our given information is 30 grams of iron, and what we want to find out are grams of O2. So this will be sort of our longest type of multi-step problem, grams of A to grams of B. So we're going to put our units of grams of Fe on the bottom, so those units cancel. Whenever you're dealing with grams, you should be thinking about molar mass. So we put the units of molar mass are grams per mole, and more specifically, it's grams for every 1 mole. We look on our periodic table, and the molar mass of iron is 55.8, and now we can see our units do cancel. We're left with moles of iron. Moles of iron isn't exactly what we want, so we need to cancel those units. So we put those units in the next conversion factor on the bottom. To get from one chemical to another, we use our balanced equation when the units are moles. So we put moles of O2 on the top. So now we grab our numbers from our balanced equation, 3 in front of oxygen and 4 in front of iron. And we're going to cancel our units of moles of Fe. So now we're left with moles of O2, and we need to cancel those out. So we put those on the bottom of the next conversion factor. And we do have a relationship between moles of oxygen and grams, so we put grams on top. And we should again recognize units of grams per mole is molar mass. So it's a certain number of grams for every 1 mole. As we said before, the molar mass of O2 is 32 grams. Again, we see that our units of moles of O2 cancel. Now it's a matter of doing the math, because the only units that are left are the units that we want. So we're going to take 30 times 3 times 32 divided by 55.8 and divided by 4, and we should get 12.9. Now something to realize here is that I chose to only look at the reactants. So, but what's important to recognize is that I could be comparing iron to Fe2O3. I could be comparing O2 to Fe2O3. Any combination. I just happen to use these examples in the problem of only looking at the reactants. But you could also say, if I had 30 grams of iron, for instance, how many moles of Fe2O3 would you make? Or if I had 30 grams of iron, how many grams of Fe2O3 would you make? And again, you could also go from oxygen to Fe2O3 as well. But that's the general process of using the factor label method. And again, we're relying on things that we already know, for instance, molar mass, and also units in our equation. Thank you for watching.